Myself, Dr. K. Vishwanath Alamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the law of parallelogram of forces. What is law of parallelogram of forces? In law of parallelogram of forces can be described in two methods. Number one, graphical method. Another one is the analytical method. Here, what is the law of parallelogram of law of forces? What is this law? This law indicates, it means that when two forces are acting on your body, the effect of the two forces can be given by one of the force. That force is known as the resultant force. The calculation of the resultant of two forces, the law which is used for calculating that resultant force, that single force, is known as law of parallelogram of forces. Here, this law is used only when two forces are acting in your body. If you want to find out the resultant of those two forces, this law is useful. The more than two forces are getting or applied on your body, if you want to find out resultant of more than two forces, this law is not applicable. Now, this law states that if two forces are acting at a point, be represented both magnitude and direction, and also the point of application. That means, by the adjacent, two forces are acting here on the point O. So we will make it such a way that these two forces are acting as two sides of a parallelogram. Then the resultant represent the diagonal of that parallelogram represents the resultant of those two forces and passing through that point. Okay, let me explain here. There are two forces P and Q are acting on the particle O. The angle between those two forces is alpha. P and Q. That OA represents the magnitude and the direction of the force P, and OB represents the direction and magnitude of the force Q. These two P and Q forces are to be considered as the two sides of a parallelogram. Then draw a parallel line to OA, that is BC. BC is parallel to OA and OB is parallel to AC. So the joining side, the diagonal, if you join, that is here the parallelogram is OACB. OACB is the parallelogram. The diagonal, if you join O to C, this diagonal represents the resultant force, the resultant of the forces P and Q. So the angle made by the resultant force with the adjacent side, that is OA, that is theta. That theta represents the direction of the resultant force R. All right. So this theta represents the direction of the resultant force R, where R represents the resultant forces of P and Q. The alpha, where alpha is the angle between the two forces P and Q. O is the particle on which these two forces are acting. The P and Q forces are acting. The nature of the force here, it is the tensile nature, because it is going away from the particle. All right. This method is known as the graphical method representation. We need analytical calculation that represents R equal to, what is the R? The analytical method, the resultant force R equal to P square plus Q square plus 2PQ cos alpha. It is under square root of P square plus Q square plus 2PQ cos alpha. This R is the analytical formula. This resultant of two forces when it acts on a particle with an inclination, the angle between them is alpha. Alright, then what about direction? The direction, yes, we are going to write here theta equal to tan inverse of Q sin alpha by P plus Q cos alpha. If you substitute, if you know the Q and if you know the P, and alpha is the angle of inclination between P and Q, then all are knowns. If you substitute over here, then we'll get the direction of the resultant. And in this formula, if you substitute the resultant, how we derived these two formulae, both the magnitude and direction of the resultant force. Okay, for that what we have to do? Let us draw a perpendicular line. Draw a perpendicular line in this figure. We are going to find out the magnitude of the resultant force. Going to find out the magnitude of the resultant force are how to find out? Let us begin with draw a perpendicular line from the point C and to the adjacent extension of OA. This AD is the parallel line or extension of OA, that the P force, and CD is the perpendicular line we have extended, then it is intersected at point D. Now the angle between P and Q, the alpha is making angle, this Q is making with the P, OP. Similarly, or OA, this alpha equal to the angle between AC, that is angle between AOB equal to angle between DAC. Okay, this is the same angle alpha. Now this AC equal to AC is parallel to OB. This AC is having the same magnitude of OB, and OA is having the same magnitude of BC. This is also P, and AC is also Q. It's the same force. It's the same force, parallelogram. We have parallel lines. They're having same magnitude and same direction. Now AC is the Q. If it represents, what is AD equal to? This AD equal to, what is AD equal to? Let us, if you understand better, cos alpha, what is cos alpha equal to? From the triangle, from right angle triangle, DAC. From this right angle triangle DAC, cos alpha equal to, what is cos alpha? Cos alpha equal to adjacent side by a diagonal side, that is AD by AC. Now AD by, what is that AC? AC nothing but a force Q. Now it is cos alpha. Now from this AD equal to Q times cos alpha. Now AD equal to Q times cos alpha. Now consider sin alpha term. Sin alpha equal to opposite side by diagonal side. What is opposite side here? That is a DC by diagonal side AC. Now what is the AC here? DC by AC equal to Q. This is sin alpha. Now DC equal to Q times sin alpha. That is Q times sin alpha. Now this is the terms here. AC equal to Q. Now here AD equal to AC cos alpha. That is nothing but Q cos alpha. AD equal to Q cos alpha. Next AC, that is CD equal to AC sin alpha. CD equal to AC sin alpha. That is nothing but Q times sin alpha. That is Q times sin alpha. Now what next? This is a right angled triangle. Now The resultant force, if we consider the next another triangle, the triangle is DOC, is the right angle triangle. Now consider our OCD or DOC. Yes, DOC is the right angle triangle. But the angle at O is what? Our right angle triangle, if you understand, from this triangle OCD or DOC. Now, what is according to Pythagoras theorem? OC square equal to OD square plus CD square. Alright. Now, OC square equal to OD square plus DC square or CD square. Now, what is the magnitude of the OC? The OC equal to R. What about OD? This is the OD equal to OA plus AD. OA plus AD. What is this OA here? The OA is Q. And what about AD term? The AD term, if we go, what is the OAD? That AD equal to Q times cos alpha. Q times cos alpha. Okay. Now, what is the, yes, OA equal to how much? It is P. P plus Q cos alpha OD. Next, one more term is there. This is the OD we know. OC equal to R. OD equal to P plus Q cos alpha. What about CD? The CD equal to Q times sin alpha. Substitute in this Pythagoras that a hypotenuse square or diagonal side square equal to adjacent side square plus opposite side square. Now, substitute here OC equal to R square, and OD P plus Q times cos alpha, that is whole square, plus Q times sin alpha whole square, that is a CD or DC, Q cos Q sin alpha. Now R square equal to what? This is A plus B whole square, A square plus B square plus 2AB. If we simplify it, that is P square plus Q square cos square alpha plus 2PQ cos alpha. Next, Q sin alpha whole square, that is Q square sin alpha. In this, Q square one term, Q square, make it common, Q square common, that is Q square times Q square of, that is sin square alpha plus cos square alpha. Now P square plus the Q square term, make it common in those two terms, similarities, that Q square times cos square alpha plus sin square alpha plus 2PQ cos alpha. Now P square plus the cos square alpha plus sin square alpha equal to 1. That Q square plus 2PQ cos alpha, that is R square equal to P square plus Q square plus 2PQ cos alpha. Now R equal to, then it becomes a square root of P square plus Q square plus 2PQ cos alpha. This is the term. Alright. This equation gives the resultant force of two forces P and Q. The angle between them is alpha when those forces are acting on a particle O. Now this is the derived formula. By using analytical method, the resultant of two forces when it acts on a particle and making the angle between them is alpha. That is the resultant force. Now, with what direction this resultant force is acting on a particle? That direction with the horizontal force, that is a P, is theta. This is again right angle triangle from ODC. From ODC is the right angle triangle. From triangle OCD or ODC. Now if you consider tan theta equal to, what is the tan theta equal to? Tan theta equal to CD by what? OD. What is the CD here? The CD term we already calculated, Q times sine alpha. What about this OD term? OD equal to OA plus AD. What is it? OA, P plus AD. AD is the Q times cos alpha. That is P plus Q cos alpha. That is tan theta equal to. This is what here. Now if we consider this, the theta is the direction of the resultant. The direction of resultant, theta is angle made by resultant force or with what? OA. Now from triangle OCD, tan theta equal to CD by OD. What is the CD? CD we already calculated, that is Q times sine alpha. AD equal to Q times cos alpha. And total OD equal to P plus Q cos alpha. That's what we substituted. OD equal to OA plus AD. OD equal to OA plus AD. This, what is that OA? P plus, what is that AD? Q times cos alpha. That is OD. What is CD? The CD equal to Q times sine alpha. Now tan theta equal to CD by OD. Substitute those two terms here. What is the CD? Again Q times sine alpha by OD. P plus Q times cos alpha. Then theta equal to, that is tan theta equal to Q times. Now theta equal to tan inverse of theta equal to tan inverse of P plus Q sin alpha by P plus Q cos alpha. This equation, this theta equal to tan inverse of Q times sin alpha by P plus Q cos alpha. This equation gives the direction of the resultant R. Now we are going to apply some of the case studies in these two. There are case 1 and first case. What is the first case? We are considering the angle made between two forces is 90 degrees. If the alpha equal to 90 degree, then what is the resultant force? Here there are two. In this case study, what is the case? First case, if the two forces P and Q act at right angles, P and Q are acting at right angles. That means what? Between them is alpha equal to 90 degree. Then this P and Q becomes what? This is the force acting on a particle O. The Q and the P. Then what about the resultant? The resultant comes, you can make it directly also. The resultant, there are two methods are there. One is graphical method, another one is, another method is analytical method. We are calculating here by using analytical method. We know the resultant force R equal to under square root of P square plus Q square plus 2PQ cos alpha. This cos alpha, in the place of alpha, substitute 90 degrees. That it becomes P square plus Q square plus 2PQ cos 90. Cos 90 equal to 0 degrees. 0 value. Substitute 0, then it will happen. The resultant R equal to under square root of P square plus Q square. Okay. The resultant R equal to P square plus Q square. You can also directly, you can also understand here. If both are equal, suppose we are considering P and it is Q. If you join it, this diagonal represents and it is Q. Alright? According to Pythagoras theorem, it is R. According to parallelogram law, the diagonal represents is the particle. The both P and Q are right angle each other. It is the right angles. The angle between them is right angle. From your side, you can make it is a right angle. So it represents Q. The horizontal side represents P. According to parallelogram, you join. Now, According to Pythagoras theorem, r square equal to, what is it? R square equal to? R square equal to p square plus q square. Now r equal to under square root of p square plus q square. This is another method. So simple method by Pythagoras theorem. So, but by we used what? Parallelogram law of forces. So if we substitute here, we have validated with the help of, by using Pythagoras theorem, the resultant force R equal to under square root of p square plus q square. That is, this is the resultant. Now, what about the direction? The direction theta here with making with horizontal, what is that? OA. You may consider OA and it is OB. Now, what is the tan theta equal to? Theta equal to, from our method, direct method, it is logic method, tan inverse of, what is the tan inverse of? Opposite side by adjacent side. That is Q by P. Am I right? We got it or not? Yes, we got it. Or if we substitute our formula, the derived formula here it is theta equal to tan inverse of Q sin alpha by P plus Q cos alpha. Tan inverse of, what is alpha equal to? 90 degrees. Sin 90 degree equal to 1. And P plus Q cos alpha, cos 90 degree equal to 0. Q times 0, again 0. That is Q by P. Tan inverse of Q by P. This is logic method, shortcut, and it is the formula derived expression. If you substitute in that expression, we got the same values. So this is the case 1. Okay. The next, what is the case 2? In the case 2, the same case study we are considering, but here the two forces are equal. That means force P equal to force Q. But the angle made between them is what? Alpha. So the two forces P and Q are equal and are acting at an angle alpha between them. The Q force equal to P. What is the resultant formula? We derived expression. The resultant expression when Q and P, for this case, that is R equal to under square root of P square plus Q square plus 2PQ cos alpha. Substitute in this derived expression P equal to Q. Then what happens? P square plus 2P times P cos alpha. Then because since P equal to Q, now 2P square plus P square, 2P square, 2P times P, 2P square cos alpha. Then 2P square make it common because the product, the factories remain same in this here. 2P square times 1 plus cos alpha. 2P square times this 1 plus cos alpha can be written by using the concepts of trigonometry, that is 2 cos square times alpha by 2. So 2P square times 2 cos square alpha by 2, that is 4P square cos square alpha by 2. So you can, in order to simplify the term, square root term you want to remove, we made like that, we substituted. Then 4P square cos square alpha by 2. What is the 4P square here? That means what happens? 2P cos alpha by 2 is the resultant. This is the resultant of what? When two forces are equal, having equal magnitude, and the angle between them is alpha, then the resultant equal to 2P times cos alpha by 2. Alright. Next, what is theta? The theta equal to direction. Again, we know that tan theta equal to tan inverse of Q times sin alpha by P plus Q cos alpha. In that substitute P equal to Q, we substituting P equal to Q. That means then our Q equal to P, then tan inverse of P times sin alpha by P plus P cos alpha. Then term make it further simplification, P sin alpha by, make it P term common, that is 1 plus cos alpha, that is P sin alpha by P times 1 plus cos alpha. Tan inverse of PP gets cancelled, sin alpha by 1 plus cos alpha. Now further we know that Sin alpha equal to 2 times sin alpha by 2 cos alpha by 2. Substitute here 2 times sin alpha by 2 cos alpha by 2. Then 1 plus cos alpha, that means 2 times cos square alpha by 2. Then there are terms will be cancelled. Then it becomes sin alpha by 2 by cos alpha by 2. That is tan alpha by 2. Tan inverse of tan alpha by 2. What will happen here? Tan inverse and tan, that is alpha by 2. So beautiful. Theta equal to alpha by 2. That is the direction with which the resultant of 2p times cos alpha by 2 is acting on the particle O, with by having what? Equal magnitude, and the angle made between them is alpha. It becomes half of that cos alpha by 2 sharing, that is alpha by 2, with that angle it acts. So how it acts? When P equal to Q, exactly alpha by 2. This is the resultant force. What here? R equal to, this is the resultant force with which it acts. Okay. There is another case which we are going to solve. Case number 3. Case number 3 is that the angle P, the angle between them P and Q are acting at right angles. That means alpha equal to 90 degree. But here one more case, the P and Q are also equal. That means P equal to Q. If P equal to Q and alpha equal to 90 degree, then for that case, what is the resultant force and what is the direction? The resultant force R equal to, we know the generic derived expression, that is P square plus Q square plus 2PQ times cos alpha. Substitute here, what is a P square and Q square? Here P equal to Q, since P equal to Q, P square plus P square, 2P square times cos alpha means cos 90 degree. Cos 90 equal to what? 0. Cos 90 means, since cos 90 degree equal to 0, then what will happen? This term becomes 0, then it becomes 2p square. So what will happen? Root 2 times p is the resultant. The resultant force when 90 degrees. We can also, this is the analytical method we express it here. It is the analytical method is root 2p. The angle between them is 90 degree. It is also p. According to parallelogram law of forces, the diagonal represents resultant. Am I right? So this is the p, this is also p. So according to Pythagoras theorem, the diagonal, that is r square equal to p square plus p square. Then r equal to, what happened? 2p square, root 2p. We got it. This is the logic method. This is by using logic method, that is root 2p, r equal to. Next, whatever direction for this case study, the direction similarly here, the p and the p is acting on the particle O. This represents R. So the angle made between them is the theta. So it is also same magnitude to P. Then tan theta equal to P by P. Then P by P get cancelled. Then what happens? Tan theta equal to 1. Theta equal to tan inverse of 1. That means what? 45 degree. It is the logic method. Let us first substitute our analytical method. By analytical method, what is the formula? Theta equal to tan inverse of Q times sin alpha by P plus Q cos alpha. The alpha here it is what? 90 degrees. Alpha equal to 90 degrees. And one more time, P equal to Q. So tan inverse of Q sin alpha. Q means P, Q equal to P sin alpha. Sin times 90 degree. Again P plus P cos alpha cos 90 degree. Then tan inverse of sin 90 equal to 1, cos 90 equal to 0. It get cancelled. Tan inverse of 1 equal to 45 degree. That is the theta. So the resultant is making how much? 45 degree on a particle. So these are in this manner you can study more and more. And the book we followed here, it is Timoshenko we followed. That is the reference one which I mentioned here. Engineering Mechanics by Timoshenko. Edition is 2019 edition. That is Engineering Mechanics. That is the reference I mentioned here. That is the source. So let me summarize what are the things we have studied here. In this law, parallelogram law of forces, we have studied what is parallelogram law of forces, what is the law, and how to find out what is the importance of this law and what are the limitations of this parallelogram law of forces. And we used both graphical methods and also analytical method. Mostly we emphasize in most analytical method, how to find out resultant by using analytical method and also by using parallelogram law of forces. So the analytical method, from that resultant force equal to when two forces P and Q are acting on a particle, the angle between them is alpha. The resultant force R equal to under square root of P square plus Q square plus 2PQ cos alpha, and the direction of the resultant theta equal to tan inverse of Q times sin alpha by P plus Q cos alpha. And we have studied 3 case studies here. In textbooks available there are 2 case studies, but we have derived one more case study, that is third case also. The case 1 is that when the angle between P and Q equal to 90 degree perpendicular normal to each other, then what is the resultant? The resultant for that case study is the resultant for case 1. The resultant for case 1 is, that is R equal to under square root of P square plus Q square, that is for case 1, and theta equal to tan inverse of Q by P. And also for case 1 we used, one is analytical method and validated with by using the concepts of parallelogram law, that is logic method we used, and we validated. The both results are agreed 100%. The case 2 is angle between two forces P and Q or alpha is alpha, but both P equal to Q. Then in that case, what is the resultant? R equal to 2P times cos alpha by 2 and theta equal to theta equal to alpha by 2. And finally, the third case is that both P and Q are equal and the angle between them is 90 degree. In that case, so interestedly we used that 2 methods. One is logic method by using parallelogram law of forces and Pythagoras theorem. We validated with the derived expression by substituting derived expression resultant R equal to root 2P, and here in logic method also root 2P. And theta also we express in logic method. This is logic method. In logic method, the theta we got is 45 degree and analytical method also 45 degrees. So validated both the methods. So with this we can stop the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.